Okay, I wanted to make a video to show that this video is totally not reality. Jeranism's challenge to the pole stars. This is not reality at all. This was made by Wolfie6020, and he's basically saying that the pole stars are above the poles. This is totally nonsense, and I'm going to explain it why. What he's basically trying to do, he has the string line going to the roof like the stars are 1,000,000 miles away from this pole. Well, this is totally nonsense, and I'll tell you why soon. He's saying that the stars spin miles away from the actual Earth. Well, this is why. Take the camera out the tripod. He's basically saying that the Earth is like that. Here's my pen. And his pole stars are spinning around like this. This is total baloney, and I'll explain why in a minute. He's basically saying that the reason why the Earth spins is it makes the perfect circles all the way out there. Well, no, that's not how things work in reality. Okay, and what I'm about to show you is the pole star is above the South Pole, and the stars actually spin around the pole star, and guess what? They meet up at the equator. They meet up at the equator. They are always going over Australia. Every day you can monitor them. This is how the stars go, and in the north they're exactly the same, spinning around, and they meet at the equator. Well, you get what I'm trying to draw here? Okay, the pole stars meet at the equator. They're always going over the top of Australia. They're never ever underneath Australia. So the ball is not spinning for the stars to be underneath the ball. They're always going over Australia. If you really want to check this out, you can go to Sky Map. You can go to Star Walk Sky Guide. You can go to Star Tracker. You can go to Star Chart, Sky View, Star Finder, Star Rover, Star Map, and this will explain exactly how the stars spin over Australia every single day, every single night. They do not go under Australia. They're always over the top of Australia. They're not at a pole star 1,000,000 miles away like what he's explaining in this video. They meet at the equator. There's plenty of star trails that show they meet at the equator. This is spinning around the North Pole and spinning around the South Pole and meeting at the equator. They're not going to meet at the equator when they're 1,000,000 miles away from the North Pole and from the South Pole. And it's due to perspective. When I'm in Australia, I'm looking 180 degrees straight up. And what I mean by 180 degrees is this is how our vision works. If you're a person here with his eye standing on the ground, okay, you're always looking 90 degrees. If you go anything under, you start off at 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. 100, 110, 20, 30, 40, 50, 160, 170, 180 degrees from perpendicular, from the zero. So basically what that means is when you look at converging lines, if you're that person here, looking the horizon always rises to that 90 degrees. The sky always comes down to that 90 degrees. And I'm going to explain a demonstration out the backyard in a minute how that actually works. You can look at converging lines down a hallway and watch how they converge down and converge up. That's how lines work. That's how our perspective works. Now I'm about to go out the back, and what we have here is another application. Like I said, 0 degrees to 180 degrees to 90 degrees. This is how the application works. And it's called Flat Earth Detector. Okay. Now what we have here are lights. What I'll do is I'll actually plug those lights in so it makes them a bit brighter so we can see them. Alright, now the lights are on. Okay, all these lights are at the same height. They're all parallel to the ground. Okay, this line on the ground is parallel to the line at the top. We can measure it from there to there, and we can measure it from that end to the ground. Okay, well this star here, this blue one right here is, we'll call it the Southern Cross. This star all the way at the end is the pole star. Okay, and this is how you see things in perspective. Okay, the blue star. If we can get that pitch to, well, if we go straight up, you're talking 180 degrees, which is that light there. Then it goes less degrees, 170 degrees, 160 degrees, 150 degrees, 140 degrees, 130 degrees. And the further you keep looking, the perspective goes down. It keeps going down to the horizon, which would be 90 degrees. Well, when you look from the ground at 0 degrees and slowly work your way 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees, 90 degrees, well, that's where these lights will end up. They will end up at that horizon line. If this went for another kilometre long, this will hit the horizon. As you can see, they converge down. They converge down to the ground. Same with the ground, it converges up until they hit that horizon line. Thanks for watching.